So I'll present the impacts of carbon price risk on land use in New Zealand. So agriculture production contributes to about half of total greenhouse gas emissions in New Zealand. And the New Zealand government has an emission trading scheme as a tool to address climate change obligations and reduce greenhouse gas emissions. In the land sector, currently only forestry in the ETS, so where forest owners receive payments for carbon sequestration. But there is also discussions to include agriculture in the ETS, where the agricultural land users will be paying like a tax will be taxed for the emissions of the carbon from land use. Yeah. And the carbon prices in the ETS market over the last 10 years have been highly fluctuating. So we can see in this figure, and I checked today the price, the most recent price was $34 per ton, and 2 months ago it was around $32 per ton, so it's going up, but maybe at some point it will go down again. It's like it was in 2012, between 2012 and 2011, 2016, it might be low again, so I don't know. So if if the carbon price will be fluctuating like this, having such variability, it will have a high uncertainty on from the impacts of ETS policies for both agriculture and forestry, if again there will be ETS also in agriculture. So the objective of this study is to analyze the impacts of carbon price risks for agricultural and forestry sectors, for considering different land use across New Zealand. So to address this objective, I used the NZFARM model, and into this NZFARM model, I also include the risk model, a mean variance approach. So the basic scheme of the model looks the following way. So we have the maximization of the certainty equivalence from all land uses. So certainty equivalent is a certain profits that land users will receive considering the risky conditions. In this case, considering the risk in carbon prices for both agriculture and forestry. And then we have these three different components. So uncertainty comes from the varying carbon prices for both forestry returns, carbon payments for forestry, carbon sequestration forestry, as well as like levies or taxes for carbon equivalent emissions from agriculture. Then we have EBITs from land users that we get from for which information we get from the industry. Then there are also management practices at dairy and sheep and beef. These are like more mitigation options to reduce greenhouse gas emissions. This information was collected during the project that we did for the biological emission reference group in 2018. So we have 6 mitigation options, management practice for dairy, different dairy systems, and 3 mitigation options for sheep and beef, for different sheep and beef types. Then maximization for the model comes considering different resource constraints, and here the main resource constraint is the land use area allocated by different risk aversion levels. So risk aversions I will explain in the next slide. And the outputs of the model are environmental, economic, and agriculture production ones. All are considering the different risk aversion levels. So risk aversion information in the model comes from the survey of rural decision makers, so provided by Pike. So it's a survey that was asked from the land users, and the main question was, are you generally a person who is fully prepared to take risks, or do you try to avoid taking risks? And the scale was between 0 and 10 of response scale. 0 means that respondent don't like taking risks. Yeah, so I assume that it's strongly risk averse land users, so they try to avoid risky situations. and 10 is fully prepared to take risks. So these are the land users that are risk neutral, so they're indifferent to risks. And here in these figures, 9 figures, we can see distribution of the responses to risk. So from 0 to 10, these are the risk aversion levels. And we can see that most of the responders are rather risk averse, which is 5. So they are risk averse, but not that strongly, and not like not hardly risk averse. So they avoid risk, but not that much. While there are also some land users who are strongly risk averse, like sheep and beef, but again, it's comparison to other risk aversion response, they are not that much. And across all land use, if you look at the bottom right figure, so this, if you take all the responses from all these 9 land users, that will be the distribution. So again, the rather risk averse is the most observed response among land users. Then assumption in the model. So I took this information from the SRDM survey and then distributed it by land use and across regions. So for example, if we have 50% strongly risk averse sheep and beef farms, let's say in Bay of Plenty region, for example, then we assume that in the baseline, like in the model inputs, the 50% of the sheep and beef farms are actually risk averse based on this survey. And another assumption is that there is no change from one risk aversion level to another. So we don't have increase, for example, in the less risk averse land users, or in the area for the less risk averse land users, or decrease in the area for the strongly risk averse land users. So I simulated 2 scenarios. One is a baseline, and another one is ETS, including both forestry and agriculture, and considered again carbon price variability and different risk aversion levels. So the model results shows the following. So the impacts on for the land use change is the highest for rather risk averse land users. Again, this is because they are the main like observed responses from the survey. So that's the main bulk of the survey. So I assume that's the most observed risk aversion land users there. So we can see here are 5 rather risk averse. So the largest area decrease in absolute terms for sheep and beef here, then followed by dairy and deer. And the largest increase comes for the forestry. And then there is minor small increase for the arable and horticultural crops. While for the strongly risk averse, R0, R1, or risk neutral, hard risk averse land use change is small, again, because there is a small observation for this risk aversion level, but also the risk preference also affected the land use change. And for specific land use of the largest change, the largest increase in areas for forestry, again, because they sequester carbon, so the forest owners receive payments for carbon, while the largest decrease is for sheep and beef in absolute terms. Again, because they have high emissions, while the EBIT is smaller. So the large area shift to the forestry, and in relative terms, in percentage values, actually the largest area decrease is for the deer. And in terms of the management practice for dairy, distribution is more or less equal. We can see it from the left side figure among the management practice adoption, but mostly adopted management practice is supplementary feeds. It's because the information that we have and based on the data, so this management practice has a lowest costs for per each GHG emission reduction. Yeah? While others, for example, reducing stocking rate or adopting forestry practices, they also reduce a lot of carbon, but they also lead to the high reduction of EBITs for dairy farm. And also such difference, not only one specific management practice, because we have different dairy system and which environmental economic performance differs also by regions. While for sheep and beef, almost 95% of total mitigations adopted. So not all sheep and beef adopt mitigations, and not all dairy adopted. Almost from 95% of mitigations that are adopted at sheep and beef are allocated for forestry, because they can increase the returns for some of the sheep and beef farms and also generate returns from a carbon sequestration.
I have 5 minutes left.
Yep, thank you. And in terms of the profit, so again, the largest effect in absolute values is for the R5, which is a rather risk-averse land users, so the highest effect. So the largest profit reduction will be for sheep and beef and for dairy, because they have high emissions of the high CO2 equivalent emissions, then a small decrease in deer profits, and the highest profit increase will be for forestry, followed by some horticulture crops. But if you look at the relative terms, actually, not in the absolute, so in relative terms, the highest profit decrease will be with the higher risk aversion level. So for the strongly risk averse, this R0, they have the highest negative effect. So this is a small sample from this survey of rural decision makers. Yeah? That's a small number, but they have the highest negative effect. So their profit reduced in total profits for this strongly risk averse, reduced from the baseline by about 17%, while for rather risk averse around 2 or 3%, 3 or 4%, something like this. Yeah. So the difference is high. And by land uses, then the largest relative profit reduction is for deer and sheep and beef, and largest increase for forestry because of the carbon sequestration revenues and increase also in the forestry area. Dairy profits also reduced because of the decrease in the dairy area, but also costs from the greenhouse gas emissions from carbon taxes. In terms of the environmental outputs, again, the largest effect on the rather risk averse land users. So there seems to be because of the bulk of the respondents are there, they also have the largest effect. There seems to be the most responsive to the policy. ETS policy is the largest reduction in nutrient losses and reduction in net GHG emissions. So these are the sum of the greenhouse gas emissions and carbon sequestration. But interestingly here is that strongly risk averse also have a small reduction actually in environmental performance. So environmental performance of the strongly risk averse actually do not improve that much, despite their profits reducing quite substantially, while their enriching is actually increasing, small but still increasing, and also risk neutral or hardly risk averse land users also don't have that much improvement in the environmental performance, So in conclusion, the study shows that there is impacts can differ depending on the different risk-averse population groups, considering the carbon price risks for both forestry and agricultural production, and the largest effect on the rather risk-averse land users, because it's also the largest sample of the population, the largest population from the survey. But if you look at the relative change, then the largest profit decrease is for the strongly risk-averse farmers, and the also strongly risk-averse farmers don't have that much improvement in the environmental performance, which actually shows that if there will be policy, we can say that the effect from these groups of rather risk-averse groups of land users will not be that much, in considering that they have higher losses, actually. And the study has actually also a lot of things that needs to be improved. So currently I only consider the carbon price risk, but there is also variability in the milk prices and meat prices or log prices. Then the yield variability also because of the climate change, and there are also other environmental policies, freshwater policies. So these things needs to be also considered in the further research. That's it. Thank you.